Close your eyes and breathe. Feel the stillness settling around you like evening mist. In this moment, you rest at the edge of something vast and gentle, a place where science becomes poetry, where the smallest truths hold the greatest wonders. You are surrounded by silence, but it is not empty silence. It is the kind of quiet that exists between raindrops, between the notes of a lullaby, between one breath and the next. This is the silence that holds everything together, though you cannot see it or touch it with your hands. Beneath your closed eyelids, beneath the softness of your pillow, beneath the solid floor that holds your bed, something extraordinary is happening. The world you know, the world of tables and walls, of skin and heartbeats, is dancing. Every atom in your body, every particle in the air you breathe, every speck of matter in the room around you, is engaged in an ancient, invisible waltz. This is the quantum world, and you have always lived within it, though it moves too quietly for your senses to detect. It is smaller than small, more delicate than a whisper, yet it is the foundation upon which everything you have ever known rests. Imagine, if you will, that reality is like a vast, still lake. From the surface, the water appears calm, mirror smooth, reflecting the sky with perfect clarity. But if you could dive deeper, past where sunlight reaches, you would discover something remarkable. The water is alive with movement. Tiny currents flow in patterns too complex to predict. Microscopic whirlpools spin and dissolve, and waves smaller than dust motes rise and fall in endless gentle chaos. This is how your world truly is. The chair you sat in today, the cup you drank from, the ground beneath your feet, all of it appears solid and predictable from your human perspective. But at the quantum level, at the scale of atoms and the particles within atoms, everything shimmers with uncertainty. Nothing sits perfectly still. Nothing follows the rules you learned about how objects should behave. In this deepest layer of reality, a single particle can be in multiple places at once, like a dancer who somehow performs on several stages simultaneously. It can spin in opposite directions at the same time, like a coin that is both heads and tails, until someone looks closely enough to decide. These particles exist in what scientists call superposition, a word that sounds complex but means something beautifully simple. They hold all possibilities within themselves until the moment they must choose just one. You might wonder how this can be, how the universe can function on such seemingly impossible principles. The answer is as gentle as it is profound. Uncertainty is not chaos, it is potential. It is the universe's way of keeping all doors open until the perfect moment arrives. Think of a garden in early spring. Beneath the soil, seeds rest in darkness, and within each seed lies not one future, but many. The seed could become a tall sunflower reaching toward light, or a spreading vine that finds its way along a fence, or a delicate herb that flavors summer meals. Until the soil warms and the rains come, until that first green shoot breaks through the earth, the seed exists in its own superposition, holding every possibility, every potential version of itself. This is what happens at the quantum level in every moment. The particles that make up your body, that form the walls around you, that dance in the empty space between the earth and stars. They all exist in this state of gentle uncertainty. They are probability clouds, whispers of what might be, dreams that the universe holds close until reality needs them to make a choice. And here is perhaps the most beautiful part. You are part of this dance. The calcium in your bones once superposed in distant stars. The iron in your blood held multiple states within the heart of an ancient sun. The oxygen you breathe participated in quantum conversations billions of years before your first breath. You are made of particles that have existed in uncertainty, that have danced between possibilities, that have chosen and been chosen countless times across the history of the cosmos. Right now, as you rest here in this quiet moment, trillions of quantum events are occurring within you. In your brain, electrons tunnel through barriers they should not be able to cross, carrying the thoughts you think and the dreams you dream. In your heart, quantum coherence helps coordinate the rhythm that keeps you alive. Throughout your body, particles communicate with each other in ways that transcend ordinary space and time. maintaining the delicate balance that allows your consciousness to contemplate its own existence. This is not science fiction or mystical thinking. This is the actual, measured, verified reality of your physical being. You are a walking, breathing, dreaming manifestation of quantum possibility. Every cell in your body operates according to principles that would have seemed like magic to previous generations, principles that still fill scientists with wonder and humility. The quantum world asks nothing of you except to exist, and in existing, to be part of the grand uncertainty that makes existence possible. You do not need to understand its mathematics or memorize its rules. You need only to rest in the knowledge that you are held by something far more elegant and mysterious than simple mechanical clockwork. As you sink deeper into rest, let yourself feel the quantum stillness that surrounds you. It is not the stillness of death or emptiness, but the pregnant pause before music begins, the held breath before a wish is made, the quiet moment when all possibilities hover in perfect balance. You are cradled by uncertainty, and uncertainty, it turns out, is the most certain thing of all. It is the promise that the universe will never stop surprising you, never stop creating, never stop finding new ways to be beautiful and strange and wonderfully alive. In this quantum stillness, something stirs. Not random motion, but the first gentle stirring of pattern, the whisper of waves that will carry you deeper into the mystery of how order emerges from chaos, how the dance of uncertainty creates the rhythms that make life possible. Close your eyes and imagine holding a grain of sand between your fingers. Feel its tiny weight, its solid certainty. Now, imagine that same grain suddenly becoming like morning mist, present but not quite there, real but somehow flowing. This is the gentle mystery you are about to enter, where the smallest pieces of everything refuse to stay still in the way you might expect. You are walking along a shoreline where the waves have been whispering secrets for billions of years. Each wave that touches your feet carries within it a story that mirrors something profound happening in the invisible world around you. The water moves in patterns, sometimes crashing with the certainty of solid stone, sometimes flowing like liquid silk. But water is always water, you think. Or is it? In the realm of the very small, in spaces tinier than anything your eyes could ever see, there exists a world where the rules change completely. Here, the things we call particles, electrons, photons, the building blocks of everything you touch, live double lives. They exist as both particles and waves, shifting between these identities like thoughts, shifting between waking and dreaming. Picture an electron, one of those tiny dancers that orbit the heart of every atom in your body. When scientists first discovered electrons, they imagined them as tiny marbles, solid little spheres spinning around atomic centers like planets around a sun. But when they tried to watch these electrons more carefully, something beautiful and strange began to happen. The electron refused to behave like a marble. Instead, it began to spread out, becoming less like a thing and more like a whisper of possibility. Imagine trying to photograph a hummingbird in flight. The faster it moves, the more it becomes a blur of color and motion rather than a clear, solid bird. The electron does something similar, but even more mysterious. When you are not looking, when no instrument is measuring or detecting, the electron exists as a wave of probability. It spreads out like ripples on a pond, like the sound of your voice echoing in a vast canyon. In this wave state, the electron is not in one place, but in many places at once, existing as pure potential, as mathematics made almost real. You can feel this concept in the way music moves through air. When someone plays a violin string, the string vibrates, creating waves of pressure that travel through space. The music is not the string itself, but the wave it creates. The music exists everywhere between the violin and your ear, filling the space with invisible presence. This is how electrons exist when they are being waves, not as things, but but as invisible presence, as patterns of possibility moving through space. Now imagine you decide to listen more carefully to that violin music. You place a microphone at one specific spot to record the sound. Suddenly, the music you capture is no longer the flowing wave that filled the entire room. Instead, you have captured just one moment, one place, one specific vibration. The wave has collapsed into something definite, something you can point to and say, "Here, the music is here." This is what happens when scientists try to measure an electron. The moment they set up their instruments to detect where it is, the wave-like electron suddenly becomes particle-like. It chooses one location, one moment, collapsing from a cloud of possibilities into a single, definite point. But here is the most beautiful part. The electron does not lose its wave nature permanently. As soon as the measurement ends, as soon as you stop looking, it spreads out again into waves of possibility. You are experiencing something similar right now as you listen to these words. Your consciousness flows like a wave through different thoughts, different images, different feelings. When you focus your attention on one specific idea, perhaps the image of that grain of sand you imagined earlier, your awareness becomes particle-like, concentrated and specific. But when you relax that focus, your mind spreads out again, becoming wave-like, touching many possibilities at once. The electrons in your brain, the very particles that allow you to think these thoughts, are dancing this same dance of wave and particle. They flow like water through the neural pathways of your mind, carrying the electrical signals that become your dreams, your memories, your sense of being you. In each moment, billions of electrons are choosing to be waves or particles, creating the symphony of consciousness that is reading these words right now. This wave-particle nature is not just a curiosity of physics. It is fundamental to how the universe creates itself, moment by moment. The light from the stars that shines down on you moves as waves across the vast emptiness of space, but becomes particles of photons when it touches your skin. The warmth you feel is the collapse of wave into particle, the moment when starlight chooses to be real for you. In quantum physics, this beautiful mystery has a name: wave-particle duality. But names sometimes make mysteries feel smaller than they really are. What you are contemplating is nothing less than the fundamental creativity of existence itself. The way the universe maintains infinite possibilities while still allowing definite experiences to emerge. As you breathe in, imagine that breath carrying within it trillions of molecules, each one dancing between wave and particle states. Your lungs, your blood, your beating heart. All of it sustained by this constant transformation of possibility into reality and back again. You are not separate from this quantum dance. You are this quantum dance, experiencing itself from the inside. The waves that created you are still creating you in each moment, with each heartbeat. You exist in the space between certainty and mystery, between being and becoming. Like the electron, you are both definite and infinite, both here and everywhere, both particle and wave. And in this gentle understanding, as your mind settles into the rhythm of this cosmic dance, you might find yourself wondering about something even more profound, about the spaces between things, about what emptiness itself might contain, and how even nothing might be more mysterious than you ever imagined. You stand before a wall that shouldn't exist, yet does. Not brick or stone, but something more fundamental. A barrier made of energy itself, rising like an invisible mountain in the quantum realm. This is where the rules you've known your entire life begin to whisper their secrets, where the impossible becomes merely improbable, and where you witness one of nature's most elegant magic tricks. Imagine you're holding a tennis ball, feeling its weight in your palm. You throw it against a concrete wall, and it bounces back, obeying every law of physics you learned in school. The ball doesn't have enough energy to break through, so it returns to you, defeated by the barrier. This makes sense. This feels right. This is the world of our everyday experience, where walls are walls and boundaries cannot be crossed without sufficient force. But you are no longer in that world. Here, in the realm of the infinitely small, you watch as a particle approaches a similar barrier, an energy wall that should be insurmountable. The particle moves like a gentle wave of probability, neither fully here nor there, carrying with it the strange mathematics of quantum existence. According to every rule that governs the world you know, this particle should bounce back, just like your tennis ball. It doesn't have enough energy to climb over the barrier. It cannot break through by force. Yet something remarkable happens. The particle approaches the wall, and for a moment, time seems to pause. You watch as the wave function, that ghostly mathematical description of where the particle might be, begins to do something extraordinary. Instead of reflecting cleanly backward, part of it seeps through the barrier, like morning mist passing through a garden gate. The particle's presence becomes distributed, existing partially on both sides of the wall simultaneously. This is quantum tunneling, and you are witnessing the universe's most beautiful act of rebellion against classical intuition. Think of it like this. Imagine you're walking through a city and encounter a hill too steep to climb. In our world, you would need to go around, or perhaps find enough energy to scale it. But what if instead, you could become like water, flowing through tiny spaces in the rock itself? What if the very atoms of your being could slip between the atoms of the hill, allowing you to emerge on the other side without ever truly climbing over? This is what the particle does, though the mechanism is far more elegant than simple seepage. The barrier before you isn't solid in the way we imagine solidity. At the quantum level, everything is probability. Everything is wave-like. Everything exists in a state of gentle uncertainty. The particle's wave function extends beyond its classical boundaries, creating what physicists call a tunneling probability, a mathematical whisper that says, "Perhaps I can be there too." You float closer to observe this quantum ballet. The energy barrier stretches upward like a transparent mountain, its peak far above the particle's energy level. In classical terms, the particle is like a marble trying to roll over a hill when it only has enough speed to reach halfway up the slope. Impossible. Yet the wave nature of quantum reality offers a different solution. The particle's probability wave doesn't stop at the barrier's base. Instead, it penetrates into the barrier itself, diminishing exponentially as it travels through the forbidden region. The thicker the barrier, the more the wave dampens, like sound growing softer as it passes through layers of fabric. But if the barrier is thin enough, some probability emerges on the other side, a ghostly presence that maintains just enough strength to reconstitute the particle in its new location. This isn't science fiction. This is the foundation of the stars themselves. Deep in the heart of the sun, hydrogen nuclei face barriers far more formidable than the one before you. These positively charged particles should repel each other with enormous force, their electromagnetic fields creating walls that seem absolutely impenetrable. The temperature and pressure at the sun's core provide some energy, but not nearly enough to overcome these barriers through classical means. Yet, fusion occurs moment by moment, powering the light that warms your face and the energy that feeds every living thing on Earth. The secret is tunneling. Quantum mechanics allows these hydrogen nuclei to slip through their electromagnetic barriers, fusing together to create helium and releasing the energy that makes life possible. Without tunneling, stars would never ignite. The universe would remain cold and dark, and you would never have come into existence to ponder these mysteries. You watch as more particles approach the barrier, each carrying its own probability wave, each facing the same impossible choice. Some tunnel through successfully, emerging on the far side, as if the wall were merely a suggestion. Others reflect back, their waves collapsing into the classical world of definite positions and predictable outcomes. The process is random yet statistical, chaotic yet governed by precise mathematical laws. This randomness isn't a flaw in nature's design, it's a feature. Quantum tunneling provides the universe with a gentle flexibility, a way for systems to explore new configurations without waiting for classical coincidences. In your own body, enzymes use tunneling to catalyze reactions that would otherwise take millennia. The very processes of life depend on particles occasionally ignoring the energy barriers that should contain them. The wall before you begins to shimmer, its meaning transformed by understanding. It's not truly a wall at all, but a probability landscape, a mathematical description of likelihood and chance. The particle doesn't break through or climb over. It simply expresses the fundamental uncertainty that underlies all existence. Where classical physics demands definite answers, quantum mechanics offers elegant possibilities. You notice how the tunneling process respects certain rules while transcending others. Energy is still conserved. The particle doesn't gain energy by tunneling, it simply borrows against the uncertainty principle, paying back the debt so quickly that the universe doesn't notice the transaction. Time and space remain coupled, but their relationship becomes more fluid, more forgiving. This is why quantum computers might one day solve problems that would take classical computers longer than the age of the universe. Quantum bits can tunnel through computational barriers, exploring multiple solution paths simultaneously. The same principle that powers stars and enables life also promises to revolutionize how we process information and understand complexity. As you observe particle after particle facing the barrier, you begin to see a pattern in the randomness. While each individual tunneling event is unpredictable, the statistical behavior follows precise mathematical laws. You can't know which particle will tunnel through, but you can predict what percentage will succeed. This is quantum mechanics at its most profound, deterministic laws governing probabilistic events, certainty emerging from uncertainty. The barrier before you no longer seems like an obstacle, but like a gentle filter, allowing the universe to explore possibilities while maintaining its fundamental conservation laws. Some particles pass through, carrying information and energy to new regions of space. Others return, perhaps to try again, or to contribute to different quantum processes elsewhere. You find yourself wondering about the barriers in your own life, the walls that seem insurmountable in the classical world of daily experience. While you cannot tunnel through your challenges like a quantum particle, perhaps there's wisdom in understanding that even the most fundamental barriers in nature are not absolute. They are probability landscapes, mathematical descriptions that leave room for the unexpected, the improbable, the gently impossible. As the last particle in your current observation tunnels through the barrier, disappearing into the quantum foam on the far side, you sense that your journey through the microscopic realm is approaching new territory. The wall that seemed so solid moments ago now appears translucent, almost welcoming. You realize that in the quantum world, every ending is also a beginning, every barrier a doorway to deeper understanding. And in this space between classical certainty and quantum possibility, you begin to sense that consciousness itself might be preparing to reveal its own mysteries. Close your eyes and imagine time as a river, not rushing, but flowing with the gentle persistence of water, finding its way around stones. In the quantum world, this river behaves in ways that would surprise even the most patient observer. Time, which feels so steady and predictable in your daily life, begins to stretch and compress like warm honey dripping from a spoon. You are resting now, in a place where particles dance through barriers as if they were made of morning mist. This dance is called quantum tunneling, and it carries with it a secret about time itself. A secret that whispers of moments borrowed and returned, of clocks that tick at different rhythms depending on where you choose to listen. Picture a small particle approaching what seems like an insurmountable wall. In your world of larger things, this would be like walking toward a mountain and expecting to step through solid rock. But here, in the realm of the impossibly small, the particle does something extraordinary. It doesn't climb over the barrier or break it down. It simply appears on the other side, as if it had stepped through a doorway that exists only sometimes, only maybe. But the truly remarkable thing isn't just that the particle crosses an impossible boundary. It's how time behaves during this crossing. As the particle approaches the barrier, time begins to slow, like a song played at a gentler tempo. The moment of tunneling itself seems to exist outside time's normal flow, neither fast nor slow, but suspended in a space between heartbeats. You breathe deeply and feel your own relationship with time shifting. Right now, as you listen to these words, electrons in your body are performing countless acts of quantum tunneling, in the neurons of your brain, in the cells that line your lungs, in the very atoms that make up your fingertips. Particles are constantly stepping through barriers that should stop them, borrowing time from tomorrow and lending it to yesterday. Scientists have discovered that when a particle tunnels through a barrier, it appears to complete the journey faster than light could travel the same distance through empty space. This doesn't break the speed of light. Nothing is actually moving faster than light should move. Instead, it's as if the particle experiences time differently during its journey, as if the usual rules of duration become more like gentle suggestions. Think of it like this. Imagine you're walking through a garden at dusk, and suddenly you find yourself stepping through a beam of moonlight that somehow takes you instantly to the other side of a hedge. You haven't moved faster than you normally move. Instead, the space between starting and arriving has become something softer, more forgiving. The moonlight has borrowed a moment from the evening and given you passage through what seemed impossible. This borrowing and lending of time happens because of probability, that gentle uncertainty that governs all quantum interactions. When a particle approaches a barrier, it exists in multiple states simultaneously. Part of it remains outside the barrier, part of it begins to penetrate, and part of it has already emerged on the other side. These aren't separate particles, but different aspects of the same quantum reality, existing in a superposition of possibilities. Time, in this context, becomes fluid. The particle doesn't experience the tunnel as a journey from point A to point B, but rather as a gradual shifting of probability from one side of the barrier to the other. The moment of tunneling spreads out like ripples on a still pond, with no sharp beginning or end, only a gentle transformation from one state to another. You can almost feel this in your own experience of time. There are moments when a minute feels like an hour, when you're waiting for something important, or sitting quietly in meditation. There are other moments when hours pass like seconds, when you're deeply absorbed in something you love, or drifting between sleep and waking. Your consciousness, in its own way, tunnels through time, experiencing it not as a uniform flow, but as something that can be soft or urgent, thick or thin. The mathematics that describe quantum tunneling reveal something beautiful about the nature of time itself. Time isn't just a backdrop against which events unfold. It's woven into the fabric of reality in ways that allow for flexibility, for moments to be stretched and compressed, for the impossible to become merely improbable. As you rest here, breathing slowly, you can imagine your own awareness tunneling through the barriers between waking and sleeping, between conscious thought and dream. Each breath carries you deeper into a state where time becomes less important, where the rhythm of your heartbeat replaces the ticking of clocks, where the gentle pressure of air entering and leaving your lungs creates its own temporal landscape. The particle that tunnels through its barrier emerges unchanged, but somehow transformed by the experience. It carries no memory of the journey, no record of how long it took, or what it felt like to exist between spaces. Yet something has shifted. A barrier that once seemed absolute has been revealed as permeable. A boundary has been crossed without violence or force, simply through the patient application of quantum possibility. You find yourself in a similar space now, resting at the edge between one moment and the next, feeling time become more gentle around you. The barriers between thoughts begin to soften. The hard edges of the day dissolve into something more forgiving. Your breathing slows, and with each exhale, you release the need to track time's passage, allowing yourself to drift in this quantum space where moments can be borrowed and time can pause. In this borrowed time, you sense something shifting in the distance, a new understanding waiting just beyond the horizon of consciousness, where the dance of particles and possibility continues its ancient choreography. Close your eyes and imagine standing at the edge of a vast ocean on a moonless night. The water stretches beyond sight, its surface broken only by the gentle rise and fall of waves. You cannot see the depths below, cannot predict exactly where the next wave will crest, or where the foam will kiss the shore. Yet there is a rhythm here, a pattern that whispers of deeper truths. This is the language of chance, and it speaks in the same voice that governs the smallest corners of existence. In the quantum realm, certainty dissolves like salt in water. The particles that build your body, that dance through the air you breathe, that flicker in the light touching your skin, they do not follow the rigid paths you might expect. Instead, they move like thoughts in a dreaming mind, guided not by fixed laws, but by the gentle mathematics of possibility. Picture a single electron, smaller than the smallest thing you can imagine. In the classical world, you might expect this particle to have a definite position, a clear velocity, a predictable future. But quantum mechanics reveals a different story. The electron exists in a cloud of potential, its location spread across space like morning mist across a meadow. It is not that we simply don't know where it is. It is that the electron itself exists in multiple places at once, each possibility weighted by its likelihood. This is probability made manifest, chance given form. The electron's position is described not by a single point, but by a wave function. A mathematical poetry that captures all possible outcomes. Some locations are more likely than others, like islands of higher probability in an ocean of potential. When you observe the electron, when you reach out to touch this quantum mist with your instruments, the wave function collapses. The electron chooses in that moment of observation to be in one place. But before that moment, it lived in the space between certainty and possibility. You might feel a gentle vertigo thinking about this. The solid world around you, the bed beneath you, the walls that shelter you, the very atoms of your being. All of it built from particles that exist in states of maybe. It is as if reality itself is a vast improvisation, with each moment bringing new choices, new collapses from the possible into the actual. Consider the path of a single photon of light, traveling from a distant star to your eye. In the quantum world, this photon does not take just one route through space. It takes all possible routes simultaneously, bending around planets, skimming the surface of the sun, threading through the spaces between atoms. Each path carries its own probability, its own weight in the cosmic calculation. When the photon finally reaches your retina, all these phantom journeys collapse into a single arrival, a single moment of seeing. This is the strange democracy of the quantum realm. Every possibility has a voice, though some speak louder than others. The electron might tunnel through barriers that should be impermeable, appearing on the other side like a ghost walking through walls. The probability is small, but it is not zero. In the quantum world, the impossible becomes merely improbable, and the improbable becomes inevitable given enough time and space. You are surrounded by this constant dance of chance. The chemical reactions that power your cells, the electrical signals that carry your thoughts, the very bonds that hold your molecules together, all of them governed by quantum probabilities. Your body is a symphony of statistical events, each note played by particles making quantum choices billions of times per second. Think of your heartbeat, steady and reliable. Each beat depends on the movement of ions across cell membranes, a process that relies on quantum tunneling. The certainty of your pulse emerges from the accumulated whispers of countless uncertain events. Your very life is built from the language of chance, spoken in quantum syllables too small to hear, but too fundamental to ignore. The beauty of this probabilistic world is not in its uncertainty, but in its endless potential. Every moment contains infinite possibilities, like seeds waiting for the right conditions to bloom. The future is not a single path stretching ahead, but a garden of branching possibilities, each one real until the moment of choosing arrives. Scientists have learned to read this language of chance, to translate the quantum whispers into human understanding. They speak of probability amplitudes and wave functions, of interference patterns and entanglement. But beneath the mathematics lies something deeper, a recognition that reality itself is more fluid, more creative, more alive than we ever imagined. You can feel this truth in your own experience. The moment before you make a decision, you exist in a superposition of choices. You are simultaneously the person who will turn left and the person who will turn right, the one who will speak and the one who will remain silent. The quantum realm mirrors this human experience of potential, of living in the space between what was and what will be. As you rest here in the quiet of this moment, you are participating in the universe's greatest experiment in possibility. Every breath you take, every thought that crosses your mind, every quantum event in your body, all of it part of the vast ongoing conversation between chance and choice, between the possible and the actual. The language of chance is not a language of chaos, but of infinite creativity. It is the universe's way of keeping itself open to surprise, to beauty, to the emergence of the unexpected. In learning to hear this language, you begin to understand that uncertainty is not the absence of meaning, but the presence of infinite potential. And as you settle deeper into rest, you might wonder, if the quantum realm speaks in probabilities, what other languages does the universe use to tell its stories?